Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Pertama sekali, terima kasih kepada semua yang sudi hadir meluangkan masa bersama-sama YPASM dalam siri webinar Apa Kata Pakar Climate Talk. So, saya Dr. Tamalia Amanda Putri Osman, Ketua Unit Sains dan Hubungan Strategik YPASM sebagai moderator pada sesi kali ini. So, pada hari ini kami menjemput seorang lagi pakar, tapi kali ini dalam bidang geobencana untuk mengupas topik hangat yang pernah mungkin terdengar di TikTok, iaitu kiamat iklim bagi menjawab persoalan, benarkah dunia akan dilanda kiamat menjelang 2040? Adakah bandar-bandar besar di dunia termasuk Malaysia akan tenggelam? Dan adakah ini berpunca dari pencarian gletser Antartika? So, persoalan ini semua akan dijawab oleh pakar dalam bidang geobencana yang kami bawakan, iaitu Dr Hafeez Jeofry. Beliau kini berada di China dan bakal mengikuti Arctic Ocean Deep Sea Exploration bersama Polar Research Institute of China pada bulan Jun ini. So, saya baca sedikit biodata beliau. So, beliau merupakan pensyarakanan program Sarjana Muda Sains Geosains Marine dari Fakulti Sains dan Sekitaran Marine dari UMT yang juga turut terlibat sebagai penyelidik bersekutu di Institut Oceanografi dan Sekitaran dari UMT, universiti yang sama. Selain itu, Dr. Hafeez Jeofry juga turut aktif dalam penyelidikan di bawah bidang kepakaran beliau yang menggunakan teknik-teknik dan analisis geofizik dan geospatial untuk memahami isu-isu berkaitan geobencana seperti memahami kestabilan lapisan ais di Antartika dan Greenland menerusi proses-proses dalaman di permukaan ais. Dengan kerana tersebut juga, beliau melihat impak kestabilan terhadap kenaikan paras laut, terutama di Laut Cina Selatan yang boleh menyebabkan hakisan pantai dan banjir di kawasan berketinggian rendah. So, sorry, tanpa membuang masa lagi, saya persilakan Dr. Hafeez Jeofry. Dipersilakan, Doktor.
Okey, terima kasih banyak kepada moderator majlis iaitu Dr. Amanda. And thank you very much for the warm welcome. I think I don't have to further introduce myself. Dr. Amanda have actually introduced myself. So I think for today I'll use both English and Malay. I hope that's fine. Ada bahagian-bahagian yang saya akan cakap dalam Malay, ada bahagian-bahagian yang saya akan cakap dalam bahasa Inggeris lah, if you don't mind. Tapi kalau di sini, kalau ada kita di international audience, then I think I'll just use English, fully English lah then. Okay, so I think I'll just share my slide first. Okay. Okay. Hope everyone can see my slide.
Yes, we can see it. Thank you,
Okay.
Dr. Hafeez.
Okay, great. All right. So today saya akan share. Actually, this is a very good question. I received this question a lot. And it is something very important because everyone wanted to know lah, semua orang nak tahu lah. Bila kita cakap pasal Antartika ataupun Greenland, bila kita cakap pasal dua tempat ni, kita selalu, yelah, kita bayangkan dunia yang penuh dengan ais. And then setiap kali kalau kita cakap pasal Antartika, kita akan cakap pasal pencahayaan ais disebabkan oleh global warming. And that is a very famous issue that I believe everyone knows about the issue. I'm not really sure about sekolah rendah macam mana, tapi if I'm not mistaken, YPASM and other university that are involved in the Antarctic research, we are doing very actively in engaging students from both the primary and also the secondary school. And I think probably among the youngsters, among the kindergarten as well, because recently we've had this collaboration with Petronas Petroscience, showcasing our research to the young children during school holidays. So I believe that this is an issue that apa tu, dah makin dekat lah, dah makin dekat dengan hati rakyat Malaysia, and I believe that everyone also dah lebih cakna lah dengan isu berkaitan dengan di Antartika ni lah, berkaitan dengan global warming, so on and so forth. And coming back to the thing that I'm talking about earlier, basically when we talk about Antarctica, we always talk about how much the ice would actually contribute to sea level rise. Okay, that's the kind of question that I've received quite a lot, mainly uh, during such as the exhibitions or the event. Like say for example, sometimes we've had the collaborations with the PSK Pusat Sains Negara or PSKT Pusat Sains Kuala Terengganu, where we are displaying our research to the school children or even to the public. They always ask this question: how much will sea level rise influence Malaysia? Adakah Malaysia akan tenggelam? Um, dan pelbagai lah soalan-soalan yang berkaitan dengan benda-benda macam tu, which I think that is actually an interesting question to me. Untuk menjawab persoalan tu lah, basically untuk menjawab persoalan tu, um, ini adalah something yang pernah berlaku berjuta-juta tahun yang lepas. Sebenarnya benda tu bukan satu yang mustahil lah. Okay, benda tu bukan sesuatu yang mustahil, yang mana lautan berjuta-juta tahun yang lepas, yang mana basically kita punya bumi ni di covered ataupun tak ada daratan, tak ada benua, memang semuanya hanya lautan saja. And that was a period where the land continent is much lower in terms of the elevation, and therefore the sea level is much higher back then. Ada juga waktu yang lepas yang mana kita menghadapi satu period yang kita panggil sebagai interglacial period. Interglacial period. So what does it mean by interglacial period? Interglacial period is actually a time in the past where the Earth itself is actually doesn't have any ice at all. Okay, it's not. We don't have a Greenland. We don't have Antarctica. It's actually a free ice world. So what happened back then was a lot of the land is actually being covered in water. Okay, tapi benda tu, proses tu mengambil masa yang sangat lama, berjuta-juta tahun. Okay, berjuta-juta tahun. Jadi untuk benda tu terjadi dalam masa yang terdekat ni, kita boleh katakan macam agak mustahil lah. Okay, kita boleh katakan agak mustahil lah untuk macam dalam lifetime kita, yang mana dalam tempoh lebih kurang kita average jangka hayat penduduk Malaysia lebih kurang dalam, saya tak sure, mungkin saya salah, mungkin dalam 70 tahun saya rasa average. Mungkin saya salah, mungkin dah ada updated data. This is actually information ni saya dapat pun dalam lama dah, 10 tahun yang lepas information ni yang orang beritahu lelaki jangka hayat umur lebih kurang 65 tahun. So I think maybe dengan gaya hidup yang sekarang ni, mungkin kita dah the average lifespan tu is much longer lah. I'm not really sure on that part. Okay, tapi coming back to my point just now, even if kita dapat hidup even 100 tahun sekalipun ataupun 200 tahun sekalipun, which is impossible, benda tu agak mustahil sebab proses ni mengambil masa berjuta-juta tahun untuk kita nampak significant impact. Tapi kalau macam tu, kenapa dia akan timbul pula soalan yang kedua? Soalan yang kedua pula, orang akan tanya, dan kenapa kita study Antarctica? Kenapa kita kena pergi Antarctica? Kenapa kena study berkaitan dengan pencairan ais? Itulah apa yang kita akan cover dalam perbincangan kita hari inilah. Okay, so basically kenapa kita study benda tu? Because mainly because the sea level is rising, because the major contribution to sea level is obviously ice sheet melting. Literally, basically in Greenland, it contributed to about 40 meter sea level, 40 or 30, something like that. I forgot already. If let's say the whole Greenland, the ice in the whole Greenland melted. For Antarctica, if I'm not mistaken, I forgot the figure. I forgot it already. If in East Antarctica, it would contribute about 60 plus meter rise, or 60 to 100. I really cannot recall that. But in East Antarctica, because it's much larger, so it holds a lot more ice. So if the whole ice melted, then it can contribute a significant amount of sea level rise. Whereas for West Antarctic ice sheet, which is on the its western counterpart, it is much smaller in size, but basically it is considered as to be much more unstable, which I'm going to present afterward. And that would potentially contribute to about 5 meter rise in sea level if the whole ice melted. So why does it concern? Obviously, areas with low line elevation, kawasan yang berketinggian rendah akan tenggelam dekat situ. In fact sebenarnya kat Malaysia sekalipun kita kita ni sebuah negara maritime nation, and basically the whole part of Malaysia is located next to the ocean, okay, and a lot of people are actually residing or living near to the coastal area. So for example, in Kuala Terengganu, okay, in the place where I'm working actually and I'm living actually, every year during northeast monsoon, we've had this issue about the coastal erosion. And coastal erosions happens due to several factors: storm surge, the atmospheric processes, and the ocean processes, and one of it is the sea level rise as well. So that's why we are studying this, because we wanted to provide information, we wanted to provide facts, data to the government, to the policymaker, in order for them to actually come up with a strategic mitigation plan on how the government can actually control this rising issue. And that's what we are doing basically. So I think maybe throughout although the title that was given to me is pencarian glacier boleh menenggelamkan dunia, I think mainly I will talk about the issue based in Malaysia. How much the sea level rise in Malaysia, how much ice contributed to sea level rise in Malaysia, what are the factors that are contributing to the sea level rise. So I think that's basically how I will proceed with the presentation. So again, my name is Muhammad Hafeez bin Jeofry. I forgot to introduce my name. My name is Muhammad Hafeez bin Jeofry. Everyone calls me Hafeez, and I'm currently working at the Faculty of Science and Marine Environment, University of Malaysia Terengganu, and I'm currently working as a lecturer at the Marine Geoscience program. So if there are any students that are interested to study about the geoscience, UMT is one of the destinations that you can select. All right, so let me start with this this slide first. And I believe that each and every one of us have at some point in our life, we've seen about this. We've seen this picture over here. It maybe not this picture specifically, but the processes. So what is this? This is actually the greenhouse effect. So what is the greenhouse effect? So to put it on simple term, basically the greenhouse effect, the solar radiation that are coming from the sun will enter our atmosphere. Once it reaches the Earth crust, it will be reflected, and then the long wave radiations would go back to the space. Some of the radiation would be trapped within the atmospheric layer, while some will actually release into the space. And the trap long wave radiations is very important because it helps to regulate the temperature of the Earth itself. So what I'm trying to say over here is that greenhouse effects is actually, it's not all bad about greenhouse effect. Greenhouse effect is actually an important process. Okay, without the greenhouse effect, the whole Earth will be very cold and it will be covered with ice, because we are not trapping any heat that are coming from the sun in our atmosphere. Okay, but over the years, especially starting from the 1850 up until now, there is more and more solar radiation that have been trapped into our atmosphere, mainly because of the greenhouse gases. So what are the greenhouse gases? Greenhouse gases include carbon dioxide, so on and so forth. Okay, so all these greenhouse gases trap these radiations and cause more and more radiation to be trapped within the atmospheric layer, and that actually causes the Earth's temperature to rise. All right, and that is what we usually call as the global warming. And global warming, in fact, basically pose a detrimental or hazardous impact to the human populations. And at the moment right now, basically, it is regarded that climate change, global warming as the the one of the most number one threat, if I'm not mistaken, to the world right now that are actually jeopardizing the survivability of the human population itself. And that is what we are studying. There are a lot of factors. There are a lot of effects that are coming from the global warming, such as one of the impact I'm going to talk about is basically the ice sheet melting itself. All right. So these are taken from the latest IPCC assessment report, AR6, where basically scientists believe that human influence have warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, oceans, cryosphere, and biosphere have occurred. And basically, if you look over here, basically there is actually a trend where the increase in temperature actually correlated with the amount of greenhouse gases that have been released into the atmosphere. And particularly, a lot of these greenhouse gases happens in between 1850 to 2020 over here. So basically, 1850 was the start of the Industrial Revolution in the Europe, and also basically all these European countries. Okay, so what happened was back then there's a lot of innovations, and there is a lot of explorations. Um, um, they were innovating a lot of technologies. Most of these technologies run by using fossil fuels. And because of that, the burning of the fossil fuel, it emitted a lot of the greenhouse gases into the atmosphere. And basically, based on the study that is conducted by IPCC scientists, they show correlations in between um, the amount of the greenhouse gases released into the atmosphere correlated with the increasing Earth temperature itself. So that's why it is believed that the current global warming is actually caused because of the anthropogenic activities, or anthropogenic. Another meaning of anthropogenic is actually human activities itself. So we are causing the global warming, and we need to take responsibility for that. So there are a lot of um, actions that have been taken, but it's not yet enough in order to control the global warming itself, the rising temperature itself. There's a lot of new innovations, new product that have been innovated throughout the years. And the purpose of that product being developed is because we wanted to control the amount of the greenhouse gases that is being released into the atmosphere. One of the product that is very famous and currently have penetrated into our market is the electrical vehicle. Okay, the EV car, electrical vehicle car, where it runs by using electrical energy. Okay, but that is one of the innovative way where we can control the greenhouse gas, but it is not as simple as ABC. There's a lot of factor that we need to consider. There's a lot of factor that actually um, allow, or I guess maybe push the people to actually convert from the fossil fuel car to the electrical vehicle. Okay, there's a lot of factors, and we need to consider about the oil price, the economy, so on and so forth. And in fact, we also, not just on the economy part, the finance part, we also need to consider about the impact to the environment, because obviously there's been a recent highlight in the social media where basically electrical vehicles solve one problems, but it creates another problem, because all the raw materials, the rare earth elements that are needed to basically build one car consumed a lot of natural resources. For example, the lithium battery, you need a lot of resources to build one lithium battery. And that lithium battery can maybe last for about 10 years, I guess, 10 years or maybe more if we basically take good care of the battery itself. So maybe it can run much more than that. But basically, what I'm trying to say over here, when we wanted to solve a problem related to global warming, it's not as simple as ABC. It's a complex issue. It needs cooperation from all the people around the world, and hopefully, yeah, we are causing the global warming, and it is our responsibility to actually control the global warming. Hopefully, all right. So, one of the impact of the global warming, right? One of the impact of the global warming, as I've mentioned just now, is basically the melting of the ice, right? So how does the melting of the ice tally connect with Malaysia? Because a lot of people actually assume that Antarctica and Greenland are located far away from Malaysia, located on the other side of the world. Okay, so if the melting happened, most of them jump to the conclusion where it won't affect Malaysia. Whereas it's actually the opposite, because Malaysia is a maritime nation. We are surrounded by ocean. All right. So obviously, if let's say in Antarctica, if it's melting, obviously it will impact Malaysia. Um, we'll talk about that in further later on. But basically, one of the impact of the ice melting that is occurring due to the global warming is the sea level rise, and the sea level rise is a long-term impact. Okay, sea level rise is not a short-term impact such as the storm surge and other processes. It's actually a long-term impact where most of the impact from the sea level rise can be seen towards the end of this 21st century. Okay, but although it's a long-term impact, it's happening. Okay, it's happening, and if we take this lightly, sooner or later, before we know it, the sea level rise have increased at a significant rate. And at that time, probably we are too late, because if it's a long-term impact, obviously, in order to control sea level rise, it's going to be a long-term mitigation strategies. So before that happen, we need to start now, okay? Because sea level rise, basically, sea level rise combined with storm surge impact, atmospheric and ocean processes, that can actually cause coastal erosion to happen. In Malaysia, we have a lot of erosion happening, especially in the east coast of Peninsular Malaysia. You can actually see from the news portal, some of the news portal that have been released. I've shown it over here, but if there's ton of media reported about this issue, you can just Google it yourself, and you can read it yourself next time. Okay. So basically, as I mentioned, sea level rise is actually a complex study. It requires experts from various fields to fully understand the causes and scale of the impact of the coastal environment. So basically, this is one of our study where we investigate the projected impact of the sea level rise on Malaysia coastal region, where we use a comprehensive analysis that incorporates key contributors outlined by the Intergovernmental Panel on the Climate Change, or IPCC. And some of these contributors include the thermal expansion, the ice sheet and glacier melting, the groundwater discharge, the glacial isostatic adjustment. I'll explain each of these later on, and how much each of these are actually contributing to the sea level rise in Malaysia. As of now, there are not, as to my knowledge, so far, if we look into the sea level rise study, most of the sea level rise study in Malaysia, we are actually focusing on how much sea level is rising. Either we use tide gauge data or we use satellite altimeter data. There are also modeling studies as well, but at the moment, so far, as to my knowledge, I may be wrong. Some of you may be able to correct me. As of now, we don't have much study in Malaysia or in South China Sea, where we investigate each of that contributor, how much that actually caused the sea level to rise. And that is why a lot of the people wanted to know. That's why a lot of people kept asking this question to me. And I think that is a good question for me. Although it's a general basic question, it's actually a very good question. How much Antarctic ice sheet or the Greenland ice sheets contributes to sea levels in Malaysia? They wanted to know that. Okay, but at the moment so far, a lot of the studies are actually reporting the sea level rise. Okay, the sea level rise, how much sea level rise. But from the increment, from the sea level rise itself, how much the sea is rising, how much is actually coming from thermal expansion, how much is coming from ice sheet, how much is coming from glacier, how much is coming from groundwater discharge, how much is coming from GIA. So that is what we are doing. Okay, that is what we are doing. And we are basically leveraging the data. This is modeling study, of course. So obviously modeling, so for some of you that have the experience to conduct modeling research, basically we know that modeling does not reflect the reality, what happened in the future, because it is based, the model itself is based on the understanding of the scientists or the mathematician that are developing the equation based on their understanding. And that is why we have a lot of models. All right, we have plenty of models, and all these models we can assume it as not correct, it's inaccurate, but we can actually validate with the historical data. So if let's say this model are able to show a good validations with the historical data, then possibly we can actually assume that the projections from this model, although it's not accurate, doesn't reflect what truly happens into the future, but at least it will give us some understanding of what to expect, what will happen in the future. That's why modeling studies is important for people to understand what happened to this future. Because obviously, in order for us to know how much sea level will rise in the futures, it's either we have a time machine where we can travel back and forth to the future, or and that is obviously impossible. So another way for us to know what happened to the future is by conducting modeling studies. Okay. So we use CIMIC 6 model, which is the latest generation of the climate model. And the study basically projects sea level changes up to the year 2100. So basically, we'll start off with the first. If you look over here, basically we have a lot of, these are um, some of the factors that are contributing to the total sea level rise. So this is total sea level rise. This is actually thermal expansion or the stereodynamic processes. This is the total sea level rise that are coming from glaciers. This is the sea level rise that is coming from the ice sheet. There is a difference between ice sheet and glacier. It's a very you can easily distinguish between the two of them. Later, I'm going to show that. This is the total sea level rise from groundwater, and this one is from the GIA itself. All right, so I'll start off with the first factor, which is the stereodynamic or the thermal expansion and heliostatic. So basically, the warming of the Earth is primarily due to the accumulations of the heat-trapping greenhouse gases, as I've mentioned just now, and about 90% of the heat energy is being absorbed by the ocean. So basically, in order for you to understand what is stereodynamic processes, to put it on a simple term, basically, when the water absorbs heat, okay, so the water molecule itself will get warmer, and the molecule will start to get further away from one another, and that causes it to expand, take up volume, and causing the sea level to rise. So it's basically a processes at a molecular level where the water molecule started to expand with more heat basically being introduced into the water itself, and that take up space, and that actually caused the sea level to rise. So basically, thermal expansions contribute to an increase in global sea levels. The temperature measurements are taken on the sea surface, either by ships, satellite, or drifting sensors such as oceanic buoy, along with the subsurface measurements and observation of global sea level rise, have shown that the warming of the upper ocean caused sea level to rise due to thermal expansion in the 20th century. Apart from that, basically because when we talk about stereodynamic processes, steric sea level is actually steric sea level rise is basically sea level rise that is due to steric processes. So when we talk about steric processes, actually involve the molecular level. And there are two processes. We call it as the thermosteric and also the halosteric. So the thermosteric sea level rise is the one that I just explained just now, which is the thermal expansion itself. What about allosteric? Allosteric is basically related to the density itself. So the density of the ocean water itself. So the density of the ocean water is actually influenced by the salt content, where the salt content changes will also affect the density of the ocean water, and that can also affect the ocean processes such as upwelling, downwelling, so on and so forth. So that are basically the two processes which can be categorized as a stereodynamic processes, which is the first one is thermal expansion or thermosteric changes. Another one is halosteric changes. All right. So basically, the ocean forms an integral part of the global water cycles. Since the amount of the water on Earth doesn't change, a change of the amount of the water in one component will be offset against the other, and the water cycle varies over time. So the amount of the water stored in the oceans changes over time. Okay, so for example, heavy rains over in Australia, Southeast Asia, and the Amazon basin will have an impact on the subsequent storage of the large amount of water on land. And that can actually cause the global sea levels to change during the 2010-2011 La Nina cycles. So this is the next factor that we are going to discuss, glacial isostatic adjustment over here. Okay, all right, glacial isostatic adjustment. So basically, what is glacial isostatic adjustment? It is actually basically the Earth is always on the move constantly. The temperature rise and fall in cycles over millions of years. So the last ice age, the last maximum glacial happens 20 million years, 20 years ago, 20,000 years ago, when great sheets of ice about 2 miles thick covered much of the Earth's northern hemisphere. And basically, what happened is that when the ice started to build up at one place, okay, when the ice started to build up at one place, it caused the land over here to deform, okay, it caused this land over here to depress, and that causes this area over here to basically rises up, okay, to basically rises up. All right. So what happened is that after sometimes basically this the ice is actually started to melt. So the wake started to drop. All right. So what happened is that when this wake dropped, a lot of this land would actually reflected back or deflect back upward. Okay. This area over here will start to uplift, and this area over here will start to subside. Okay, and eventually when there's no more ice over here, the shape of the earth itself would come to the isostatic equilibrium, where it will be the same in all areas. So that is actually glacial isostatic adjustment over here. All right. So next would be all right, glaciers. So what is glaciers? Okay, what is the difference between glaciers and also ice sheet? Where basically this is based on the definitions inside the equation that we are using. Basically, for the equation itself, we wanted to distinguish between the ice sheet, where the ice sheet actually represent the ice that is coming from Antarctica and also Greenland. So when we talk about, based on the equation itself, when we talk about the ice sheet, the total sea level rise caused by the ice sheet is actually either coming from Antarctica, or it's actually coming from the Greenland itself. So for glacier is actually the contribution of the ice that is coming from places other than Antarctica and also Greenland, such as the mountain Alps, areas in the Russian regions, the Iceland, so on and so forth. That is basically we define based on the equation itself. We define glaciers as the ice contributions that are coming from places outside from Antarctica and also from the Greenland itself. And this is the ice sheet. Okay, this is the ice sheet. So basically, ice sheet itself, as I've mentioned, it is one of the major causes of the sea level rise, and it is coming from two large ice sheet in the world, which are in Antarctica and also in the Greenland. So basically, according to IPCC report, Greenland and Antarctica have been losing mass since at least 1990, and the highest loss rate occurred, if I'm not mistaken, in 2010, 2019, and they are actually projected to continue to lose their mass. The continued ice loss over the 21st century is virtually certain for the Greenland ice sheet and also for the Antarctic ice sheet. Um, so throughout this presentation, I think I'm going to focus more on the Antarctic ice sheet, mainly because that is the region of where I've been doing a lot of the research. And basically in Antarctica itself, if you look over here, as I've mentioned just now, in Antarctica, it is divided into two. We have the larger East Antarctica and we have the smaller West Antarctica over here. East Antarctica, if it's melted, it will contribute to a significant rise of sea level. But for the West Antarctic ice sheet, it is much smaller in size, and it is if it's melted, the whole of the ice melted, it will cause around rise about 5 meter in sea level rise. But although this is much smaller compared to its eastern counterpart, scientists believe that West Antarctic ice sheet are much more unstable compared to the East Antarctica. And the reason why it is much more unstable compared to East Antarctica is because most of the ice over here is basically grounded on a bed that is actually located below the sea level itself. And whereas for East Antarctica, most of the ice is actually grounded on a bed which is located above sea level. And what different does it mean? Basically, the difference is because when this ice is grounded on a bed, meaning to say that it's actually located on top of a bed that is located below sea level, it goes to show that the ice is actually in direct contact to the warm ocean water. Whereas for East Antarctica, because the ice is located on a bed, like it sits on top of the bed where it is actually above the sea level, it is not in direct contact with the warm ocean water itself. So basically what happened is in Antarctica, a lot of us studied about the impact of the ocean warming towards the ice sheet dynamic itself, particularly in the grounding line locations. So I'm going to skip this slide, I guess. But yeah, I'm going to show this slide over here. So what is this? Basically, I've told you about the grounding line just now. Okay, so before we wanted to understand further about how the ocean itself regulates or basically um, um, causes the ice to become unstable, let's look at the cross section of the West Antarctic ice sheet first. So this is the ice, the marine ice sheet in the West Antarctic ice sheet. As I've told you just now, basically the ice is actually grounded on a bed which is below sea level, which is in the case for the West Antarctic ice sheet. But for the East Antarctic ice sheet, basically the bed is located is actually located above the sea level. So the ice grounded on the bed does not directly expose to the warm ocean water. So this is the cross section of the West Antarctic ice sheet. Over here, you can actually see this is the grounded ice. So the grounded ice also also known as ice sheet. So we call this as ice sheet. All right. And then as it goes towards the ocean downstream area, we can see that this is the ice shelf. It's different from the ice sheet. Ice sheet basically referred to ice that is grounded on a bed, whereas ice shelf basically referred to ice that is already floating. Okay, it's already floating, but it is still attached to the grounded ice sheet. Okay, some of its weight is basically supported by the grounded ice sheet. Okay, so what what I'm saying over here is that the ice shelf itself um, have possibly partially caused sea level to rise because some of its weight have been partially displaced into the ocean, and that actually cause the sea level to rise. Okay, um, but it does not yet cause a full or total sea level rise because some of its weight is still being supported by the grounded ice sheet. Okay, whereas for iceberg over here, okay, iceberg over here is basically ice is a freely floating ice. Okay, iceberg initially a part of the ice shelf, so this is what we call as ice front. Okay, this is ice front. So basically what happened is that when this ice shelf become unstable, where especially the front part of the ice shelf is no longer able to be supported by the grounded ice sheet, there's this process, we called it as the ice calving. All right. So the ice calving will form the iceberg. So the iceberg is a freely floating ice, and it has actually fully displaced its mass into the ocean, and it has caused a sort of like a total sea level rise. Examples that I can give about this iceberg is actually, if let's say, for example, you have an ice water, you put ice inside the water. If let's say the whole ice melted, the water inside the cup will not spill over because the ice itself have already displaced its mass into the water, causing the sea level to rise. Okay, but before we put the ice, okay, before the mass is being displaced into the water, let's say we have a cup full of water and the water level is at this level over here. Okay, at this level over here. All right. If let's say we put the ice inside, obviously the water will rise because the ice have yet to, the mass have yet to be displaced into the water, causing the water to rise. But once basically all the ice melted, then basically it will the water level will remain because the mass has already been displaced into the water. Okay, so the grounding line, this is the grounding zone, but I wanted to focus on this grounding line, the G symbol over here, the grounding line. So what is grounding line? Grounding line is basically the area where it is the boundary between the grounded ice and also the floating ice shelf. Okay, it is the boundary over here, and this is where this is basically the area where we are studying. We are studying the ice sheet dynamic in this area, where this area, if let's say we have the warm ocean water, the warm ocean water will cause the melting on the underside of this ice over here. Okay, so the melting will start over here, and if the melting becomes significant, the grounding line can be retreat further inland. It will retreat further inland if the melting continues over here. Okay, so once this grounding line retreats further inland, okay, this ice shelf over here, the front part of the ice shelf may no longer be supported by the grounded ice sheet. Okay, because it becomes much more unstable because this grounded part is retreating further inland, and that is why the ice calving process occurred, because the front part of the ice itself can no longer be supported by the grounded ice sheet. Okay, so usually the grounding line, the way where we investigate the grounding line location, meaning to say the boundary between the grounding line, between the floating ice shelf and the grounded ice sheet. The way we usually do that is by using satellite images. So this is the satellite images. So from this satellite image, how do we delineate the grounded ice and also the floating ice shelf? So usually we would depend on the feature of the ice surface itself. If you look over here, basically this area over here is actually much smoother compared to this area over here. And the reason why is because this area might be floating, where on the under the ice is actually an ocean water. Whereas over here, it is grounded, where basically any subglacial geomorphological feature that is presented in this area might be reflected on the ice surface. And that's why we have a much rougher surface on this one. So based on this information, depending on the methods that glaciology used, we would try to delineate. Either we use a quantitative or qualitative methods. We would try to delineate the locations, and that basically how we define the locations of the grounding line itself. So this is the MOA grounding line. This is the MOA grounding line. Basically, the MOA grounding line, we basically qualitatively draw the line based on that feature. But there are also other grounding line that we considered, where we use a quantitative method to calculate the slope, the depression of the slope, in order for us to define the area of the grounding line. In some cases, there are also other grounding line where we also considered the tide as well, the ocean, the ocean tide. So what does ocean tide mean? Basically, okay, this ice shelf is actually floating, all right? But during low tide, the ice shelf might be grounded on the bed, okay? But in some cases, when especially during the high tide, the ice shelf will be floating. Okay, so some of the grounding line, the methods that the scientists use, some of them they could also consider the tide effect as well. So that is the grounding line, and this is basically the ice stream. So what I'm trying to say about the ice stream is basically there are region in ice. Basically, the ice is not stagnant. One thing that we need to know is that ice is not stagnant. The ice is actually flowing from upstream to downstream, from high elevation to low elevation. And the area where the ice is actually flowing much faster compared to its neighboring area is what we call as the ice stream. So ice stream is basically a fast flowing ice. It is actually in the form of a stream, and that is why we call it as ice stream. This is just, I'm going to go this very quickly. Basically, if you look over here, this is basically a subsurface profile. We use electromagnetic wave, we use radio wave to understand the basal conditions. So if you look over here, basically, this is the bed topography, this is the ice surface, this is the ice. This is sort of like, if you look over this, you can try to imagine this is sort of like X-ray. If you go to the hospital, you are taking an X-ray of your body, you can see the inside, the skeleton, the ribs inside your body. So this is more or less the same principle, except that we are actually scanning the earth rather than we are scanning our body. Okay, so over here is the back topography, and if you look over here, the rough surface, all right, actually cause the ice to flow much slower. Okay, much slow over here because of all this spike over here that actually control the velocity of the ice. In some areas, we have a smoother bed topography, such as this one over here. We have a smoother bed topography. And since it is much smoother, so there's less friction force acting on the ice over here. So it causes the ice to flow much faster. And that is why in some areas we have a fast ice velocity, whereas in another area we have a much slower ice velocity. So this is the marine part. Basically, as I mentioned to you just now, basically we're investigating this area over here. This is actually a very sensitive area. The warm ocean water basically chew away the ice on over here, causing the grounding line to retreat further inland. And most of the area in the West Antarctic ice sheet, the bed topography is actually deepening upwards. The grounding line over here is actually resting on a bed on a steep reverse back slope, meaning to say that it's actually getting deeper over here. So it's actually unstable. It's not a flat terrain. It's actually a deepening terrain. So this grounding line, when it's retreated further inland, it actually goes along this steep reverse back slope. So it's actually the condition actually promotes the grounding line to retreat further inland because of the geomorphological features. And as I've mentioned to you just now, once this gets further retreated further inland, the part of the ice over here would become unstable, eventually becoming iceberg, and that actually caused the sea level to rise. The ice shelf itself is also very important. Even though the ice shelf have partially displaced its mass into the ocean and caused a partial sea level rise, it is still very important because it provides a mechanical back force support to the ice sheet over here. Without the ice shelf, the ice sheet over here will just directly go into the ocean. Okay, because there's nothing, sort of like nothing that actually support the weight of the ice sheet itself. So these are some of the news that have happened 3 years ago. We can see over here, this is basically the Weddell Sea sector. It's a part of the West Antarctic ice sheet. The A76 ice sheet is currently the world's largest ice sheet, broke off from the Ron ice shelf in May 13, 2021. Another glacier that is located in the West Antarctic ice sheet, which is the Twites Glacier, has been dubbed as the Doomsday Glacier because scientists believe that it is inevitable. It is inevitable. The glacier will just keep losing its mass into the ocean. So coming back to the sea level rise topic just now, I've already explained each of the factors that are associated to the equation I'm going to that I showed you just now. Coming back to the sea level rise, a lot of people are actually telling, especially Malaysia, are actually telling that the Antarctic and also the Greenland melting doesn't really contribute to sea level rise in Malaysia. Is it true, basically? So I've come up with a simple analogy to actually demonstrate why the Antarctic and also the Greenland melting will have an impact into Malaysia, okay, especially the low-lying coastal area. So let's look at this analogy, the bathtub analogy. All right. So you turn on the tap water on one side. Okay, the water is filling up inside the bathtub. If you put like there's a sinkhole, if you put like a blockage over there, the water will just continue to be compiled inside the bathtub and increases. Okay, so eventually the water will spill over. Okay, eventually the water will spill over. All right, so let's apply this analogy to Malaysia. Okay, let's apply this analogy to Malaysia. Just imagine the tap water itself over here is actually Antarctica or Greenland. Okay, this is the Antarctica and the Greenland is the tap water. You turn on the tap water, meaning to say the ice is actually melting in Antarctica and also Greenland. Okay, you are filling in the water inside here, but you are not filling in the water over here. Let's say this is Malaysia. The Malaysia is located over here. All right, this is region where it's much closer to Antarctica. Thus, the water inside the bathtub only increases on one side, whereas the water over to this side is not increasing. No, right? It's actually the water will become eventually will be leveled and causes the whole water in this section to rise up. Same goes to Malaysia as well. Although Antarctica and Greenland located further away from Malaysia, the ocean itself is continuous. The ocean itself is continuous. So if you have a rise on one side, it will level the other side as well. And that's why Antarctica and Greenland melting, although it's far away from Malaysia, obviously it will cause sea level rise to Malaysia. And that's why we are studying those impacts. So I think I'm going to skip this slide because I'm running out of time. But I have this study that we have conducted. Based using the equation, we use the variable, we use the thermal expansion, the glacier isostatic adjustment, the contribution from the ice sheet, the glacier, and also the grounded discharge. So this is basically a study that we have conducted to study about the sea surface height in Malaysia until 2100. So this model is actually done by my students. If you look over here, basically you can actually see that over the year, the sea level is projected to rise until the late 21st century. The sea level change from this simulation basically integrated impact from melting ice sheets, the glacier, aerodynamic processes, glacier isostatic adjustment, and also the groundwater discharge. So when we basically compile the results into 2030, 2040, 2070, and 2090, this is basically where this level will rise up to 1.5 degrees Celsius. This is the condition where the global temperature rise to 2.0 degrees Celsius. This is 3.0 degrees Celsius, and this is 4.0 degrees Celsius. So basically by 2030, this level will increase by 9.5 to 18.5 millimeter. By 2040, will increase up to 30.9 to 45.8 millimeter. By 2070, it will increase up to 162 to 190 millimeter. by 2090 will increase up to 251.8 to 293.9 millimeter. And by 2100, basically the sea level would rise up to 324 to 370 millimeter. So in order for us to investigate whether the sea level would actually inundate the area, we need to have another variable. So now we know how much sea level is rising. Okay, now we know how much sea level is rising. We need to know the land elevation. Okay, we need to know where is the low-lying area, which is where is the high elevation area. Obviously, for the low-lying area, if it's much lower, then basically if the sea level rise increases, then obviously it will inundate the area. So this is the result that I wanted to show you, how much each of the variables that we have talked just now, how much each of that actually contributed to the sea level rise. So when we break it down, basically the ice sheets during the early 21st century, we can actually see that ice sheet contributes the most to sea level rise in Malaysia in the early 21st century, and that followed by the stereodynamic changes. Melting ice from land glacier contributes little in the early 21st century, but it increases as we approach the end of the 21st century. And that also correlated with the groundwater discharge and also the groundwater discharge and also the stereodynamic processes as well. So where basically during what I'm trying to say over here, during the early part of the 21st century, ice sheet contributes the most. But as we approaches the end of the 21st century, the contribution from the ice sheet becomes less. Whereas for stereodynamic processes from the thermal expansions, it becomes much more significant compared to ice sheet towards the end of the 21st century, where it contributed in the 2100, it contributed to 49.1% of the total sea level rise in Malaysia. And that also goes for the glacier and also the groundwater discharge, where it kept increasing towards the end of the 21st century. However, it's actually a different case for glacial isostatic adjustment. Remember that the land rebound. Once we no longer have the weak loading on top of the land, it rebound. So it actually shows a negative contribution, and this may be the cause because Malaysia is actually part of the rebound. So the land is actually uplifted in Malaysia. That is what we believe in. The land is actually uplifted. So if you have even if you have the sea level at this level, it does not increase or decrease. But if the land itself is actually uplifting, then obviously you can see that the sea level becomes lower, because it's not because the sea level is changing, it's because of the land is changing itself. And that's basically what happened in Malaysia. We believe that the land is changing. That is actually an assumption. To get a much better evidence, we need to measure the land elevation in Malaysia in order to confirm the modeling studies over here. So basically, to answer whether Malaysia will be inundated by the sea level, obviously, as I've mentioned just now, it's the process is going to take a long time, millions of years. But basically, what we are trying to do over here, basically, we are looking at the impact towards the vulnerable region, the vulnerable coastal area, the low-lying area. There's a lot of factors that we need to consider, not only the sea level rise, the sea level itself, we also need to consider the land elevation itself. We also need to consider about the groundwater discharge, how much groundwater is actually being extracted, and what will happen in that hollow space where there was once the groundwater inside. What will happen to that hollow space? Because this is the case that happened in Jakarta, in Indonesia, which is our neighbor. It is actually sinking, and currently the Indonesian government, they are actually relocating their administration to Kalimantan, and the reason is because of the groundwater discharge. So what happened is that when they extracted the groundwater, the land will sink. Because there's no more there's no pressure that actually can help to maintain the land elevation. So the land is sinking, and that actually caused the sea level to rise. So a lot of factors that we need to consider in order to assess how much land area is being inundated in the future. It requires commitment from everyone: geologists, geoscientists, atmospheric scientists, oceanographer, modeler, a lot of us needs to basically work together. We need to study, we need to understand these processes so that we can actually come up with a solution to the government, what the government needs to do in order to help control this issue, especially in the vulnerable low-lying coastal areas, the area that is prone to coastal erosion, as the one that I've shown you just now earlier during this presentation. So to summarize, basically, sea level is a long-term impact. Potential significant changes happens towards the end of the 21st century. It is important for us to comprehend factors that contribute to sea level rise in Southeast Asia, because it may help us to understand the sea level pattern as well as the states that are heavily affected by the rising water. And the reason we all do this is because we wanted to provide we wanted to invite information to the policymaker, to the government, so that they can make informed decision, better mitigation plan and strategies to help control the geohazard itself. So I think that's it from me. I've taken a bit more time than I supposed to, but thank you very much. And if you have any question, you feel free to ask me the question. I'll pass back the session to our moderator. Thank you very much.
Thank you very much, Dr. Hafeez Jeofry. Terima kasih di atas perkongsian yang diberikan. Semoga perkongsian ini dapat memberi ilmu yang baru bagi kita semua. Ada sebarang soalan ke daripada penonton kita hari ini? Okay, ada one question from my FDPM Jennifer. Can you explain more on why you think that Malaysia land can be lifted up if the sea level rise? And how can the land can be lifted up?
That is a good question. Thank you very much, Jennifer, for the question. That is actually a good question. At the moment, so far, like I mentioned in the presentation just now, that is based on the modeling studies. So from the modeling studies, it shows that the glacial isostatic adjustment contributed to a negative increment of the sea level. So we believe that is due to the land being uplifted from the model itself. Okay, but obviously, to answer your question, I don't have the specific answer to your question yet. That is a good question. So in order for us to confirm that, obviously we need to measure the land elevation itself. But what basically, if I could, I'll try to explain as simple as I can. We think maybe because the land itself, okay, when we have the weight, the ice loading on top, the land will be suppressed. Okay, it will suppress. Okay, but when we remove the weight, it will rebound. Okay, we believe Malaysia is part of the rebound area, and that is why sea level is decreasing due to glacial isostatic adjustment. That is what we think. But in order to answer your questions more accurately, obviously more testing needs to be done. We need to measure the land elevation as well. Hope that answers your question.
Thank you, Dr. Hafeez. So we have one more question from Dina. She says, thank you for the great sharing, Doctor. I do have a question. What's the difference of SLR calculation with Nahrim's SLR study?
Okay, that's also a good question as well. Basically, Nahrim actually have produced several reports. To me personally, Nahrim did a very good job in terms of bridging between the scientific community with the government. They have come up with a few reports. Back in the days in 2010, if I'm mistaken, basically their sea level rise report mainly use data from tide gauge and also from satellite altimeter, meaning to say they are taking the measurements directly in the area based by using either the tide gauge stations or they are using the satellite altimeter. But they have produced a much more recent report in 2017, if I'm mistaken, 2017. So in 2017, I'm not really sure. I think they are still using tide gauge and also satellite meter, but most throughout the report, they are focusing more on the modeling work. So the difference between my research and also the NARIM is that I'm not using satellite or tide gauge. I'm using modeling data. Okay, I'm using modeling approach to understand sea level rise. Whereas NARIM, they are taking the measurement. They are taking the measurements to collect to understand the sea level. Okay, but coming back to the report in 2017, basically in 2017 they published a report by using modeling data as well. The difference between their model data and my data is that it is actually coming from the same report, IPCC report. But IPCC report, as we know, basically IPCC report every 5 years they will update their data. They will release a new set of report every 5 years. So the last back in the days, 10 years ago, IPCC AR5 was released in 2013. Was released in 2013, where they use CMIP5 model. Okay, CMIP5 model are based on scenarios based on RCP, which is the relative concentration pathway. Okay, that was back in 2013. And when NARIM released the report in 2017, they are using the CMIP5 report. Now we have a much recent IPCC report, AR6 report, which was released a few years back. Okay, in the next few years from now, obviously there will be AR7 assessment report 7, but that have yet to come. Now we are actually using AR6. In AR6, as I've mentioned, obviously every time they come up with a new report, we have a much better appreciation. We have a much better understanding of the sea level studies itself, of the Earth processes itself. So that's why we kept on improving the model. Okay, we kept on improving the model. We kept on improving the scenario. Last time we used scenario based on business as usual, but this time we also considered the social aspect of the human activities into the scenario, where we are actually looking at the activities on how we control the emission of the greenhouse gases. We are looking at that as well. So the scenario is also improved. So basically, based on the AR6, we use the SSP scenario, SS socio-economic something pathway. I cannot recall. You can just Google it yourself. Okay, so that scenario is actually and that model CMIP6. This study I use CMIP6, whereas NARIM use CMIP5. Okay, so my data is actually coming from the updated report from the IPCC, and I believe that NARIM is actually working on to produce. I'm not really sure. Probably the NARIM personnel over here can actually, if maybe can add on that if they are here. Basically, NARIM, I think they are updating their report. Okay, they are updating their report based on the latest finding. I'm not really sure. So I guess that if let's say they are updating the report, maybe they are going to use the same model that I'm using right now, which is based on the latest IPCC report. Thank you.
Okay, Alina, did Dr. Hafeez answer your question? I hope he did. And the next question is coming from Muhammad Fauzi. Cakap, Assalamualaikum and good afternoon, Dr. Hafeez. I am just curious about how much significant force needed to be exerted on the ice shelf in order to break into an iceberg.
Okay, that's basically a physics question. It depends. It depends on the area. Okay, it depends on the area. Obviously, for different area, there are different force that needs to be exerted in order to break the iceberg. It also depends on the morphology as well. It depends on the ice thickness itself. There's a lot of factors that we need to consider in order to calculate that. But I don't have the specific answer to that question. What I can say is basically there's different variables. Depends on the thickness of the ice. If the ice is thick enough, then maybe it has much more strength to support the weight of the ice shelf. It depends on the bed as well. If let's say the grounding line is located on a steep reverse bed slope, which one is much more unstable? Is it the grounding line that is located on steep reverse back slope, or the grounding line that is located on a flat bed? Which one is much easier for the grounding line to retrieve? It depends on that factor as well. It depends on the thickness of the eye shelf. If it's thick enough, then maybe it has more mass. All right. And if it has more mass, then maybe the grounded eye sheet may not be able to support the weight of the eye shelf. But if it's thin enough, maybe it has less mass. So probably it may be able to support the weight of the eye shell. So a lot of factors are involved in order to calculate that.
All right, thank you so
Mm.
much. I have just one, maybe a simple question. I was referring
Yes.
to your students' prediction on the sea level rise punya picture just now. Kalau
Mm-mm.
can see dekat the area Melaka Strait tu macam not as high the level compared to the South China Sea.
Yeah.
Mungkin Dr. Hafiz boleh explain a little bit.
Yeah, that's actually great observation. Good observation. Um uh Basically the sea level in the South China Sea part, whether it's on the East Malaysia or the East Malaysia or Sabah and Sarawak or the eastern coast of Peninsular Malaysia, it is much higher compared to the sea level in Strait of Malacca and also the Sulu Sea. Um, we are not sure. We are not sure why. But I guess maybe it has to do. It has maybe to do with the narrow, with the area of the sea as well, the strait as well. So we are trying to find the reason behind that as well. At the moment, we're not really sure, but that is actually a good observation. That is really a good observation. We are trying to look over to some of the literature review whether they have some answers to that. But at the moment, yeah, it is true. Strait of Malacca, the sea level is much lower. The Sulu Sea also it's much lower, but over to the central, the South Chinese Sea part, either in the eastern coast of Peninsular Malaysia or the east of Malaysia, the Sabah Sarawak, the sea level is much higher. Yeah,
Yeah.
yeah.
All right. Thank you so much for your sharing today. There seems that there's no more question from the audience. Okay, we hope to see you again, Dr. Hafiz. All the best for your science Arctic journey in
Thank you
June,
very
right?
much. Thank you. Yeah.
Okay. Thank you semua yang hadir pada
Okay.
hari
Thank you very
ini.
much.
Jumpa lagi bulan hadapan ada webinar yang lain dengan topik yang menarik lagi. Terima kasih. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. And thank you very much to YPASM for inviting me. I'm happy to share, and hopefully, in the future, I can also contribute more to YPASM and also to our people as well. Thank you very much. Bye.
Thank you, Dr. Hafiz. Bye. Is done.